Lake Effect brings you conversations about what's happening in Milwaukee and the people, places, and organizations that shape our community. This is Lake Effect Spotlight from WUWM, Milwaukee's NPR.
UW Milwaukee is a research university and often makes contributions to multiple fields of study. Some of those contributions come from the field of water studies. And while you've probably heard of the School of Freshwater Sciences, which studies our Great Lakes, there's another body of water the university studies: the Pacific Ocean. More specifically, volcanoes that live on the ocean's floor. That is where UWM Associate Professor Julie Bowles does her work. She spoke with WUWM's Jimmy Gutierrez about what it looks like way down below the surface, where these ridges take form.
So if you think of the Earth as like an apple, so the skin of the apple would be the crust, and that's what we all walk around on the surface. And the crust is broken into a bunch of pieces like a jigsaw puzzle, and they move with respect to each other. The mid-ocean ridges are the places where you're making new crust. So you get deep material from deeper in the earth, from the mantle, that rises up to close to the surface. And when it rises up, some of it melts. And that's what makes these volcanoes, right? And you're basically forming new seafloor at these places. And so 70% of our surface is covered by the oceans, and so 70% of our surface is made at these volcanoes.
And it feels like it'd be really important to understand where these plate tectonics are pushing together or pulling apart.
Right. So this is where they're pulling apart. That's where the ocean plates are being born, and then basically where they're dying is the other end of the process. So the plates move away from these ridges, and then eventually the plate will encounter another plate, say a continental plate, and then the ocean plate is more dense, so it gets kind of forced underneath the continental plate and forced back deep down into the mantle. So it's kind of this recirculation process. So you're making new crust, it's moving away, and then it's eventually being recycled back down into the mantle. It basically looks like a mountain range, a linear mountain range that just extends for miles and miles and miles. So it's maybe a couple of miles tall, it has volcanoes at the top, and it just extends to the horizon and beyond.
And this is all on the seafloor?
And this is on the seafloor, yeah. You can't see very far in front of you because the light doesn't penetrate that deep in the ocean. So when you're right at the summit, it looks like gray volcanic rocks that maybe have some sediment piled up on top of them. Some of them look a little glassy. There's often fissures, kind of collapse pits. If you're really lucky, you might see a hydrothermal vent community. So the cold ocean water gets down into the crust, into the rocks, through the faults and the cracks, and then it heats up because of all the hot kind of volcanic activity below. And then that water exits the seafloor in really focused places like a geyser kind of. And you get these kind of amazing biological communities that thrive around these vents. So this last expedition was a collaboration with some colleagues at Scripps Institution of Oceanography, which is in San Diego. It's part of University of California, San Diego, and some colleagues at Boise State University in Idaho. And
I love it that Idaho and Wisconsin are just in the middle of the Pacific Ocean
great.
studying volcanoes.
So we all met up in San Diego, and then we spent 11 days driving down to the South Pacific. Once we got there, what we were interested in looking at is kind of how often these eruptions happen and how big they are. Are they kind of clustered together in time? And if so, like how are they clustered together in time? So in order to do that, we had to actually get samples from the seafloor, and we had to be able to see the seafloor as well, to have an idea of what the seafloor actually looks like. We had a couple of different specialized scientific vehicles that we were working with. One is called an autonomous underwater vehicle, and this particular one is named Sentry. It collects a lot of data, so it collects information about the shape of the seafloor. Kind of high-resolution picture of where there are small kind of volcanic mounds, where there's faults, where there's fissures. It helps us to decide where we might want to go to collect samples and to look more closely. Our target was basically the summit of this ridge. And then ideally, we would want to collect actual rock samples. And we would want to see with our eyes as well what's down there. So there's a small submersible, like a little mini submarine that fits 3 people.
This is a safer submersible than the submersible we may be familiar with.
Yes, it's designed in a totally different way. And actually, there's a titanium sphere that the people sit in. And that sphere was actually forged right here in Milwaukee, in Cudahy, which is pretty cool.
We have so many connections to the Pacific Ocean.
I know.
We should name it the Milwaukee Ocean.
We should. So I got to sit in the Milwaukee sphere and go to the bottom of the ocean. And the submersible has these robotic arms, so that lets you collect samples and manipulate equipment if you were doing that as well. So then we could go down and we could actually see what it looked like, and we could collect samples that we could take back home and work with.
You're in the middle of the ocean doing this study for not a short amount of time. What did you see when you were out there that made maybe the research more difficult?
Yeah, we definitely ran into more challenges than we were expecting. It's really only safe to launch both of these vehicles when the waves aren't too chaotic or too big and when the winds aren't too high. We definitely had a few days where there was a lot of movement on the ship. I think especially when the ship is underway, like when we're not just sitting there. I always get at least a little bit seasick, at least at the beginning of the trip. We finally ended up having what we thought was going to be a decent window of a few days towards the end of the cruise where we could get maybe 3 or 4 dives in a row. But then, unfortunately, there had been 2 or 3 sharks in the area, which is not unheard of. The ship is sitting there for a long time. The lights attract kind of squid and smaller fish, and then the sharks are probably attracted by those because they feed on them. And at first the sharks were just kind of curious and they weren't really a concern. But towards the end, there were kind of more sharks coming and they were starting to display more aggressive behavior. And so curious sharks aren't really a problem for the swimmers, but sharks that are coming at you is a little bit more of a concern. So there's a small little workboat that they launch for the swimmers. And they were putting kind of sticks in the water to fend off the sharks, and the sharks were like lunging at the sticks.
Okay.
So at that point, the decision was made that
let's not put people in the water.
No people in the water. No more dives. It's not worth risking anybody's life or health for this.
Absolutely.
By any means. So
I think about folks in Milwaukee because we have Lake Michigan very close, which is also great for UWM to go and study and have access to. And I feel like we generally have a appreciation for maybe like smaller bodies of water in the state. I think something that we don't think about, though, as much as how the oceans, these ginormous bodies of water, as you said, covering 70% of this earth, affect us in our everyday lives, affect things like climate. So what should we know more about the ocean and the way not only just the volcanic presence and this history affects us, but also these huge bodies of water?
Yeah, I mean, I guess thinking at a couple different time scales. So if we're talking about the volcanic process and this process of plate tectonics, this kind of overturning of Earth's mantle that I was talking about, that process over millions of years or hundreds of million years is part of the process that kind of cycles carbon kind of into and out of the atmosphere and between the deep Earth. And so over very long time scales, that's kind of helping to moderate our climate on Earth. If you want to talk about kind of shorter time scales, the water has a huge role on Earth's climate. So the water, whether it's in the ocean or whether it's in Lake Michigan, water can absorb a ton of heat without changing temperature very much. So compared to the land, the water can absorb a lot more heat. So it's this big heat pump in a way, the ocean is. So it absorbs a lot of heat at the equator, and then the ocean currents redistribute that heat around the Earth. If we didn't have the ocean currents, the temperature would probably be kind of hotter at the equator, and it would be a lot colder at the poles. So it also has kind of a big moderating influence on our climate, in addition to being a big carbon sink as well and affecting climate that way.
So you had this expedition, hit the summit, faced all these obstacles and challenges along the way, had what looks like, via the pictures, an incredible ping pong tournament as well. I know you're doing this part of it, which is very analytical, and the research part of it, but are you ever like awe-inspired by the time that's passed or what you're seeing? How do those kind of things hit you?
Yeah, it's kind of crazy. I mean, people have certainly done work in this general area before, but the specific places that we went to and that we were able to dive down in the submersible, like literally no person has ever laid their eyes on that spot on Earth before. And it's just kind of crazy to see this thing that is this eerie, otherworldly place that no one's seen before. And very few people get the privilege of seeing.
Julie Bowles is an associate professor at UWM. She studies volcanoes in the Pacific Ocean. She spoke about her work with WUWM's Jimmy Gutierrez.
You can find more interviews like this one by visiting wuwm.com/lakeeffect. And while you're there, subscribe to the Lake Effect Spotlight podcast.